So a very popular question that we get asked by customers and designers is, can your system be used to help me solve and protect some important trees on my site, whether they be heritage trees or aged trees that you just are interested in keeping, and maybe it's part of a tree ordinance where you're simply just not able to simply cut those trees down, maybe replant. And I'm here to say that our system has been used many a times for simply creating an elevated walkway system that spans over and helps minimize the damage to those root systems. My name's Jason Philbin. I'm a registered engineer, and I'm the owner and CEO of PermaTrak North America. And we've encountered this issue many times, from Florida to the state of Washington here in the United States of America. I'm happy to explain to you today how we did that and how we worked with a designer here in North Carolina, where I live, and explain a real life project that took place several years ago. And this was a project for the campus of Wake Forest University in Winston-Salem. And we worked with a design team, Stimmel and Associates. And they helped us identify 4 main challenges on this particular application for PermaTrak. Number one was, whatever solution was chosen, they wanted something that would be ADA compliant, and it would remain ADA compliant throughout the life of the structure. So not only did the structure take on a profile where the boardwalk sloped upwards and downwards, there had to be some attention to detail to how and when the slope was, and there were some maximum slopes that we had to apply to. So for example, you can't span, or you can't slope any steeper than a 1:12 slope, for example, and you'll see that in some of the pictures of this solution there for the campus of Wake Forest. Also, challenge number 2 was and this is probably the most important one for this particular project, was whatever solution was chosen had to minimize the impacts to the tree. Because I think it's pretty evident to you that if a sidewalk was poured on grade, the trees, as they mature and grow and move, a sidewalk simply would be too rigid and would crack and would heave. And you've seen that many a times. If you've walked around downtown areas, you'll see that, where trees are parts of downtown settings, sidewalks are cracked, and you'll often see where sidewalks have been grinded and shaved to extend the life of the sidewalk. So here's an example where an elevated boardwalk system like the PermaTrak system could be used as a permanent solution, minimizing the tree impacts. And by elevating the sidewalk, you are creating an air gap that allows the air to flow under the system and still allows moisture to get to the trees. Second part of this challenge with minimizing the impacts is, wherever the foundation or supports are for the boardwalk system, it needed to have minimal impact on the critical root zone. And I'll get into that here in a minute on what that specifically means. And so there are considerations from the structural engineer as well as the arborist. And we worked with the arborist and the consultant, Stimmel and Associates, in developing a solution that worked for the owner, Wake Forest University. The third challenge that was important to them was student safety. And what I mean by that is, if you think about the texture of the boardwalk system itself, they could have simply made this out of wood. It would be very slippery. It would not have lasted under the tree canopy of the tree. You think about a lot of leaves and debris, and it becomes very slippery. So there needed to be something that had better slip resistance. And they wanted a material that could have a color to it that would blend in with the environment of the campus of Wake Forest. So safety and ADA were key to the owner. And then the fourth, but it's definitely not the least most important, was the maintenance team for the campus of Wake Forest. It's their responsibility to maintain any of the amenities that they build and include in the campus of Wake Forest. So there's a cost associated with that. There's time, there's materials in going out and repairing and correcting and fixing whatever those amenities are. So in this case, the amenity is a people walkway, or what we would call a boardwalk system. So here's how the process started. We worked with a designer at Stimmel and Associates. They identified the width and the length of the boardwalk and the location of where they wanted the boardwalk to go. And you can see that from the image on the screen. You see the trees that are off to the east side of the boardwalk, and the boardwalk was going to be squeezed between where the trees are and where the parking lot is. So it was a very specific location on where they wanted this to go. And the trees that have been identified were some heritage oaks that were very important to the campus of Wake Forest. And if you've ever been to the campus, you'll see many of these heritage oaks that are on the campus. Beautiful trees. So one thing we had to quickly learn about was the critical root zone and how it applied to our wishes on where we wanted to put the support system. So the critical root zone is something that an arborist educated us on. And the CRZ, the critical root zone, is basically a circle or a radius that emanates from the center of the tree. And based on the diameter of the tree, a good rule of thumb is that whatever the tree diameter is, that becomes in inches, that becomes the radius of circle of where it's extremely important that you minimize the damage to that root system. So you think about a conventional boardwalk system where supports are drilled and extended into the ground, and they could be 10, 15 feet into the ground. But it was important to minimize not only the quantity of pier supports, but also come up with a different type of pier support system. And the PermaTrak system offers a precast pier system that basically sits on the ground. So you're not drilling and extending a pile into the ground and damaging or trying to go between roots, which would be nearly impossible to do. But so the precast pier system sits right on top of the ground. So we worked with Stimmel and Associates and the arborist. The step one was we prepared a engineering drawing that showed where the piers would be, where the precast piers would be. And our sweet spot is to put 2 piers every 10 feet. So if you had a 100-foot long boardwalk, you would put 2 piers every 10 feet. So you can imagine that would be 10 sets of 2 piers along the length of the boardwalk system. So we prepared that drawing. We gave that to Stimmel and Associates. Stimmel and Associates and their survey crew went out into the field. They identified where those piers would be located. And they quickly found out that based on where the tree is located and where the roots are, some of the roots were exposed. They decided that some of the piers simply could not be on this modular 10-foot spacing. So we went back to our engineering team. We took the CAD file that was prepared by Stimmel and it located where the root system was, and we shifted and adjusted where the piers are. And our boardwalk system does allow the lengths of the piers to be just about any length you wanted. So we had some shorter beams than 10 feet. We had some 8-foot, some 7-foot beams, and 6-foot long beams. And then we had some beams that were 12 or 13 feet. And that was okay. I mean, that allowed us to span and position piers that would be important to not damaging and impacting the tree root system. Also important to know, and this was given to us by Stimmel in the survey, was what is the elevation of the root system? How high vertically do we need to be with our boardwalk system? So our engineering team prepared a profile of the boardwalk system, and you can see from this image here of where, not only where the piers go, but where the slopes were. And again, remember, we had to remain within ADA compliance. So that forced us to some degree in deciding where the landings would be. ADA compliance allows you to run 30 feet, and then you have a landing, and then you can slope again. And so we combine those challenges with where the existing roots are to come up with the profile that you see on the screen here that was basically the solution, the profile and elevation solution for spanning the tree roots. This is a picture that shows you what the pier system looked like. On the right-hand side, you'll see that the pier system can consist of 3 components. There would be the conical shaped piece on the bottom, which bears directly on the ground. The second component is the riser, and the top one is the cap. And the cap is what receives the 2 beams that land on the top. We don't always have all 3 components. Those beams could simply rest on the conical shaped piece on the bottom on the base if we didn't need the pier to be as tall. And you'll see in the finished photo that because of the elevation of the root system, in some cases, our piers did include all 3 components. And in some cases, it only included the base. It simply depended on how close to the ground the beam system needed to be. The pieces are modular. They're shipped on a flatbed truck. They're delivered to the job site. And you can see on the left, basically how these pieces are stored at the job site. These pieces weigh anywhere from 60 to 140 pounds, and they can be handled quite easily with light lifting equipment or with eye bolts, and lifted and set in place by 2 people. And this is a picture of the finished product. You can see one of the protected trees on the right-hand side. The root system extended from the right of the picture to the left. It went under the boardwalk system. The final product is a sandblast texture that provided a very good slip resistant surface to it. And the color that you see in here is a darker brown color, a color that we call Savannah Brown. It's one of our offerings that you'll see on our website, as well as that was used for this campus here. Since this particular project, there are now 2 other projects on the campus of Wake Forest that uses a matching color, that Savannah Brown color. Also, you'll notice that the boardwalk slopes as it goes from one end to the other. And we did not exceed a 8.33% slope, which is just simply 1 on 12. And we spanned over the root system for the boardwalk. So the campus also wanted a railing system, a metal railing system. You can see here is a black metal vertical picket style railing system that was attached and top mounted to the boardwalk system itself. And this boardwalk system has been there for now almost going on 10 years. I've been on the boardwalk several times because my son attended the campus, University of Wake Forest. I used to go across this a lot. My son lived in the dorm that you see in the picture on the top left. Walked over this many times. It's performing very well. There's no damage to the boardwalk system, and that's after 10 years. And we would expect this boardwalk system to last 50 to 75 years without any maintenance at all to it.